Welcome friends to the part 7 on functional interface. In this video, we will see a hands-on session on what we have learned in the previous couple of videos on functional interfaces. So in this video, we will see how do we give definition to this functional interface, which is a calculator, using the classical way, anonymous way, and using the lambdas. So let's quickly jump into the implementation. So the first part is using the classical way, right? So for this, what I do is I define a class calculator. I define a class calculator IMPL which implements calculator, and I will override or give definition to the add method. So nothing special till now, it is usual Java. I'll give definition which is a plus b. So far so good, there is no problem till here. Now let's call the add method and print the sum. So I'll declare the main method, and in the main method I'll create an instance of calculator. I will say calculator equal to new calculator calculator IMPL, and I will say sysout of calculator.add of 20, 30. Right? So I have not done, this is the usual Java stuff. There's nothing complex about it. I have an interface. It happens to be a functional interface because we just have one abstract method. To call this or to give definition to this calculator interface, we have defined IMPL class which overrides the add method. I create an instance of this class and call the add method on it. Ideally, we should get the sum as 50, right? Perfect. So far, so good. Now let's quickly see how do we do the same thing using an anonymous in a class. So let me just bring this towards the bottom and comment it. And let me do an anonymous in a class. For anonymous in a class, this is all that is required. I will call the add method on this calculate object reference. Right, so let me just add some right. So we have seen how do we implement it using an anonymous in a class. As you know, my anonymous in a class does not have any name. There is no name to the class, but what it ideally does is this class implements the calculator interface and overrides the add method. And here I use this object reference and call the add method, passing these two variables. Right? So far so good. We have also seen how do we use an anonymous in a class. Now let's see it with a lambda. Let's see this with a lambda. With a lambda, as you know, it's quite similar. So let me just I will just use this because this is the method that will convert into a lambda. Okay. So this is the method that we will be converting to a lambda. So what we have to do, let's apply the rule. Rule number 1 is remove the access modifier, remove the return type, remove the method name. Because of type inference, we can remove the data types. Because it's just one statement in the lambda, we can remove the curly braces, and also because we have removed the curly braces, we will have to remove the return. And by adding the arrow symbol, this would convert this into a lambda. This lambda is a definition that we have given to this abstract method. So this lambda is the definition for the add method, and this add method belongs to the calculator. So this lambda is of type calculator. So let me just do that. So friends, one important rule, whenever you declare a lambda, it has to be linked to a functional interface, and in our case, this lambda is linked to a functional interface of type calculator, right? And sys out, we will say sum lambda equals calculator dot add of 20 30. Right? Let's run it and see what is the result. Ideally, we should have 50 again, and perfect. So this, my friends, is the 3 implementation of a functional interface. So just a recap. A functional interface can be implemented in multiple ways. One is using the classical way, one is using anonymous way. But the most precise, or the most convenient is using a lambda. Thank you. Hope you guys love this video. Hope to see you in the next video. Till then, bye.